Hopefully you did not have too much trouble with this bell work. This is a review of factoring by grouping. And remember, we factor by grouping whenever we have 4 terms. And if we look at problem number 1, we do have 4 terms, right? We have 5n cubed, then we have negative 10n squared plus 3n, and then we have the negative 6 here. So we do have 4 terms, which means we will factor by grouping. That means I'm going to group together the first 2 terms and factor, and then I'm going to group together the second 2 terms and factor. So let's look at the first 2 terms. The first 2 terms, I have 5n cubed minus 10n squared. The biggest power of n that I can take out that would go into both of those would be n squared, so that's going to come out. And 5 goes into 5, and 5 goes into 10. So I can take out a 5. And in parentheses, that will leave me n minus 2. Okay. That takes care of factoring the GCF out of the first 2 terms. Now let's look at the second 2 terms. I can take a 3 out, right? So I can take out a positive 3. And if I take out a positive 3, what would that leave me inside parentheses? Well, what would I have to multiply this 3 by, right, to get 3n? Well, the answer would be n. And then I would have to have a minus 2 here, because if I multiply positive 3 times negative 2, that would give me the negative 6 that we're looking for here. Now I'm not finished. The only thing I have done is I have factored the GCF out of each term. Okay, now look and you'll notice that n minus 2 is the common factor, which means I can now take n minus 2 out. And once I factor out n minus 2, what's left is 5n squared plus 3. And since we are multiplying, the order that you multiply doesn't matter. So this is actually the answer. 5n squared plus 3 multiplied by minus 2. Let's look at problem number 2. On problem number 2, I'm going to take these first 2 terms, take out the GCF, then I'm going to look at the second 2 terms and take out the GCF, and then we'll just go from there. If I look at the first 2 terms, I have x cubed plus 7x squared. Luckily, I can take out an x to the power of 2, right? Because x to the power of 2 will go into x to the power of 3, and it will go into x to the power of 2. That will leave me x plus 7 and if I look at the second 2, I'm going to subtract a 2 here, and that will leave me x plus 7. Now, sometimes we get a little turned around with the negative sign. Sometimes I get turned around with the negative sign, especially at the end of a long day, right? So let's check this. I know that negative 2 times x is negative 2x. That's good. That checks. And then if I multiply the negative 2 times this positive 7, that does give me negative 14. So I know that I factored correctly so far. And luckily, I can see that I have an x plus 2 that's common. I'm sorry, an x plus 7 that's common. So I can take out the x plus 7. And what's left over is x squared minus 2. So the answer is going to be here. And finally, let's take a look at problem number 3. On problem number 3, we will go back and we will look at the first 2 terms again. And we will look at the second 2 terms. If I look at the first 2 terms, I can take a 4 out and a p squared. For some reason, I have a really hard time with my 2's here. Let's try this again. And let's see, if I take out a 4p squared, I think that's going to leave me a p plus 2. So let's check that. 4p squared times p gives me 4p cubed, that's good. And then 4p squared times 2 gives me 8p squared. So I did that correctly. And in the second 2 terms, the only thing I can factor out is a 3. So I'm going to say plus 3. And that will leave me p plus 2 as well. And we can check and verify that that's correct by using the distributive property. And let's do that, right? I've got 3 times p, which is 3p, and then 3 times 2 is 6. Now that I can see that I have p plus 2 common in both terms, I can take out p plus 2. And what's left over is 4p squared plus 3. And here's the answer here.